Today we will discuss the curvature of a graph because we need to know more about the shape of the graph than where it is increasing or where it is decreasing. Suppose in this context, we will consider a simple linear production function, that is y equal to fx. F prime x, that's the first order derivative of the production function, is increasing in the initial time, then it will decreasing. So this means the rate of increase for a production function varies with the number of x of workers. There here x means the workers or labor, y is the output or production. So when the x increases, output or production also increases. That's why we are saying that simple linear production function, this is the short run production function, is an increasing function. So now at the first, the additional output, that is new worker adds to the production process, increases as specialization and cooperation take place. In this figure, this shows the curve of such a production function, that y equal to fx, and this is the curvature of this production function or graph of this production function originate due to law of diminishing marginal productivity. So note that this is an increasing function. This production function is also the increasing function of x. However, the graph has a two shape. First, 0 to a amount of labor employed, and beyond a amount of labor employed, that is greater than a amount of labor employed, the curve has changed. From at the point a, the curve has changed its curvature. That's why this point is called the point of inflection. Point of inflection means the curve changes its curvature from one to another. From suppose here the curve changes its curvature, and this point is called the point of inflection. Now for x, that is the lever, this is the lever x, between 0 to a, the marginal product of labor is increasing 2. For x, that is lever, is greater than a, the slope decreases. This is the slope decreases. Suppose here if you take a slope of this function, this and this, if we take a slope of this point, then we get this slope decreasing. So this is the question, that when the labor employment is bigger than the a, the slope decreases as x increases. So at this point, suppose this point is L, this point is the point of inflection from which the curve changes the curvature, and the economic significance is of this point is that the if the labor employment increases further more with the constant of capital from A, then the productivity of labor will decrease. That is, the marginal product will be decreased. And you know from the first semester that at this point, the marginal product is 0, and then the marginal product will be negative. And that's why we do not take the negative portion of the production function. So this is an increasing production function, but there is a two shape of the graph, that is from 0 to a amount of labor employment. We see that the marginal product or slope of the function is increasing, but After beyond the point A, that is greater than point A, then the slope of the production function decreases. So the responsiveness of inputs on outputs is not homogeneous. Is not homogeneous for each point of the production function. In this case, we should know the curvature of a graph. So now we will focus. Now we will focus the for next discussion. Okay. So we will go to the next. So in this function, we already discussed this, that we are considering here a linear production function y equal to fx, and we already see that there is a two shape of the graph of the production function. There is a two shape. One is a increasing yeah, that is if you increase one additional input or worker or labor, then its response is greater than that's the marginal product is high, and then the marginal product will decrease. So this is the two shape or two stage of production. So here y is output, x is worker. So x lies between 0 to a. Already I discussed the slope of production function, that is f prime x is a increasing function. That is the derivative of f prime x, that is f double prime x, is non-negative, and and this is non-negative. You see that f double prime x is non-negative on 0 to a, and x greater than a, that is labor amount is greater than a, then f prime is decreasing. So f double prime is negative or equal to 0 for labor is a to infinity. Orthat, that means if labor employment is increasing beyond a, then the second order derivative of the production function, that is f double prime x, will be negative and equal to 0. So we can conclude that we find the two shape of this graph. One is f double prime, when f double prime x, that is the marginal product, is increasing, that means the concave up, and when the derivative of so when the marginal product is decreasing, that is second order derivative is negative, then this portion is called concave down. So if we go the previous, so this portion is concave up and this portion is concave down. So we find that there is a two shape of this graph. So this graph, the shape of this graph is not homogeneous in each point or each set of output and input combination, but it is there is a two shape of this graph. So first shape is called the concave up, and second shape is the concave down. So this is the basic idea of the graph, or the concave up or concave down. We now focus there is a different type of concave and up and concave down function. Here we find that an increasing function can be concave or concave down on its interval of increase. These two cases are illustrated in this figure. How a decreasing function can be concave up or concave down on its domain. Note the slope of the f is increasing function of labor or x for a function which is concave up, and is a decreasing function of x for a function which is concave down. So there is also a non-calculus definition of concave up and concave down. This characterization follows from the observation that for a function which is concave up, so concave up from and then the second line line, that is the joining 2 points on the graph, lies above the graph. And for any, suppose for any 2 points we are considering here, that is A and B, 2 points, that is this is point A, this is point A, and this is point B. So we are considering the set, that is capital IB is the A and B, all convex combination of this domain, that is A and B. We are considering 2 points, and this, from this to this, there is a set of convex sets in this domain. When the second line will, if we connect from A to B, then this domain illustrate the convex sets. So now we will go to the previous. So all the convex combinations of A and B already I said. So so the all convex combinations of A and B. So IAB is identity 1 minus K into A plus KB, where K is a arbitrary constant and whose value lies between 0 to 1. The graph of the production function above AB is the set of points, that is 1 minus K plus KB, and A function of 1 minus KA plus KB, which is lies between 0 to K1. So, so the graph of F above IB, so the graph of, suppose this is the graph, and the points above the graph, this domain, this domain, all are these domain, all are the convex sets, all are convex sets. So now convex sets. So on the other hand, the second line, this is our connecting line, is called the second line. Second line joining the points AFA and BFB, 2 points on the graph of AF is given. So we can write the equation in this way. So 1 minus K into A and equal to 1 minus KA plus KB. If we modify, then we will get, and for K is in 0 to 1, K value lies between 0 to 1. So now we will go to, this is our diagrammatic representation of the graph to find out the convex sets from a convex domain, that is A and B. From A to B, we get the convex sets in this domain. So the definition of this concave up, or which is called the convex, simply convex, is the a function F is called convex function or concave function on an interval, that is interval is A to B, will be 1 minus K F A plus plus K F B less than equal to F function of yes, sorry, this is the convex on an interval I, that is this function, sorry, concave R for convex function, when it will be convex R for convex function of an interval, that is interval is A to B. This is the F 1 minus K function. F is a function, that is 1 minus KA plus KB and less than equal to 1 minus KFA plus KFB for all A and B. That means between domain A and B, all the sets where the K's value is 0 to 1. And for the concave down, that is simply we can explain as a concave on interval A and B, that will be the F 1 minus K A plus KB greater than equal to just opposite of the convex function, that is 1 minus K F A plus KFB for all A, B between the sets I, B, that is the between A and B domain, all K lies between 0 to 1. So, so concave up is nothing but this is simply called the convex function, and where is concave down is simply called the concave, simply called concave function. So simply, if we want to understand the convex and concave function, one only needs to know where if sorry if sorry, this is the if double prime x double prime x is greater than 0, that is the any function's derivative is greater than 0, then this will be called the convex function. Whereas if double prime is 0, then this will be the concave function. This is the test to see whether a function is convex or concave. This mimics the test used to determine whether a function is increasing or decreasing, but uses second order derivative instead for the first. So to check the curvature of a graph, we want to check the second order condition or the second order condition will give you the curvature or the shape of the curve of a graph. So first one finds those points where the f double prime x f double prime x f double prime x is equal to 0, f double prime x is equal to 0, and solving this equation for x, these points are called the second order critical point. Then we will get a value, that is the value of x or any inputs, and then we will solve, suppose also solving this equation, then we will get a value of x. This we will get a value of x. So x, and these points, when we will find the value of x, so these points are called the second order critical points of function f or any function. If the second derivative actually changes the sign, there is already I said this is called the inflection point or point of inflection of any function we are considering here, the function f. So f, when we find any changes in the sign, then we can interpret that there is a point of inflection of the function f, there is a change in the curvature of a graph or function. So these points divide the domain of function f into interval, that is we are considering here is a and b, this is our interval and this is our domain, on each of which f double prime is always positive or always negative. On any one such interval, one need any evaluate the f double prime at a single point in the interval to determine its sign throughout the interval. So we should erase them. Then we'll come to a simple example. How to work this. Okay, fine. So now we will go to a simple example on this to find out the So fx fx is equal to x3 minus 3x. If you take derivative, that is f prime x equal to, it will be 2x square minus 3, sorry, 3 minus 3. So using the first order derivative, we determine f is increasing or decreasing from infinity to x equal to -1, decreasing from x equal to -1 to x equal to +1, and increasing again from x equal to +1 to infinity. Using only the first derivative test, we find the graph of function f. Say here is a function f, could be conceivably be composed of three straight line segments, and this is your, you can check it that there will be the three segment of this graph. So thank you. Um, so we can derivative of this equation, and we will try to find out the curvature of the graph. And similarly, for a single value, variable, we can check this. We can check this. What will be the curvature of a curve, and whether the curve has a point of inflection. That means whether the curve changes its curvature after a point, after a certain time, after a certain increase or decrease in input or labor employment. So this is our simple analysis of the concave and quasi-concave, or convex or concave function. And this is the distinction between, simple distinction between the concave and convex function. So thank you for watching this video.